All right, next up, our chief scientist, Dr. Morgan McGuire, will tell you about some exciting developments in the Roblox engine. An interesting fact, Morgan designed the scalable graphics for the very first version of Roblox back in 2005, and he was the leading game technology professor in academia. He invented many of the features used across the industry today, and right now he leads all of our R&D efforts on the engine. Welcome to the stage, Dr. Morgan McGuire.
Thank you, Nick. I'm Morgan. I'm here to tell you about the Roblox engine. The Roblox engine is one of the key differentiators of our technology stack. It's unique across the industry. It's very different than the way other 3D engines are built because we built for social and we built for scaling first. This is what powers our metaverse. The Roblox engine is what's executing simultaneously on your device, your phone, your tablet, your laptop, your console, and in our cloud. Our CTO, Dan, told you about our tech stack, which we own all the way down, and at the edge data centers, we have 15,000 multi-core processors. Each of those is also running the same Roblox engine. The Roblox engine is built on a concept of distributed computing. We can do work simultaneously throughout that entire cloud and simultaneously directly on player devices. This gives us three tremendous advantages. The first is because we leverage local computation that includes local rendering, we have incredible responsiveness no matter what network connection you're on. So you can have a ping, a latency across the network of 100 milliseconds or 1,000 milliseconds, and because we can run the physics and the graphics directly on your device, we don't have to wait for a round trip to the server like other engines do. So incredible responsiveness. The second feature of our distributed computation is it gives us very high player counts. Now, player counts lead to social density. For social 3D, the key is not just having a large number of players, but having them in the same world and able to interact with each other. So by putting more players in the same world, by distributing the cost of the computation, we're able to get more interactions between players, more social. And finally, because we're distributing that computation, we're able to run incredibly efficiently in those edge data centers. Each one of those 15,000 plus servers is able to run hundreds of Roblox worlds on it. This is in contrast to traditional game servers where a single server node might give you one or two instances. So incredible density, both for the social side, for the player experience, but also for lowering our operational costs by leveraging the processing power that every player is bringing to that network. From this base of performance and scalability, we have a lot more performance overhead than you would expect from a tech stack. And because of that, we are able to leverage it to build an advanced avatar sequence, and that gives us unbounded creation. And unbounded creation is what drives our growth. Let me tell you a little more about this. Creation on Roblox is radically different than in other 3D systems. It's because of this power. We don't limit what you can create to maybe just making new static maps or tweaking a couple of the properties of an individual object. We don't limit the scope of avatar creation. On Roblox, you can create anything. You can build a machine and bring it to life. You can write full program code if you want. You can invent new kinds of interaction modalities and new interaction loops. And you can design everything as a creator about identity and expression. You can make sneakers, you can make dresses, you can make facial expressions and animations. You can create whole avatar bodies and combine them. Powering this social 3D space, it's not about frame rates, it's not about screenshots. That's how traditional games were marketed. We're competitive on that, But the key is that we are focused on empowering individuality for our players and for our creators, and about scaling, distributed computation for scaling. So let me show you some highlights of features that we shipped in 2022. And everything on the Roblox engine, as one of the gems of innovation in the company, this is the central focus for our Roblox research academic style team, as well as our in-house R&D teams in day-to-day engineering. So you've seen throughout this morning's presentations the great strides we've made on avatars. From 2006, look at where we've come in 2022. And these are all user-created avatar bodies I'm showing you here. We now have much more diverse hair and other personal items, and we're expanding the set of avatars available. What's most exciting about the avatars is that in 2022, we released the ability to have what we call the layered clothing feature, and that gives you custom outfits. Now, many platforms, many video games have custom outfits you can buy for avatars. The key to the Roblox system is that we don't limit them to whole body outfits or a small set of avatars. It's about mix and match. It's about combinatorial explosion. So you see, our clothing and avatars have no limits. You can take a shirt, a dress, a tie, earrings, hair, and you can put them on any avatar. Now, in the real world, imagine you go out and you buy a sweater. You didn't buy one outfit when you bought a sweater, like in a traditional game engine. You actually, by buying one thing, have doubled the total number of outfits in your closet, because you can take everything you used to wear in combination, and now you can wear it with or without your new sweater. And when you take that multiplicative power through every item in your closet, you have this literally exponentially growing set of outfits that you can make. Now, we all know this from the real world. That's how things have always worked. The technology for doing that in a virtual environment is extremely sophisticated. It's because you have to make all of the clothing adjust to different avatars, different animations, different sizes, and you have to make it so that it can layer, specifically so that under layers don't poke through the above ones. Now, almost no other real-time system has tackled this problem. It's tremendously technically difficult. We solved that problem. We solved it for an unlimited number of layers and for many different kinds of clothing, and we shipped that this year. And it saw tremendous adoption. This is what drove combinatorial explosions of outfits on our platform. It makes it so that every new piece of content released is magnifying every other piece of content. It's not just one additive piece. Shortly after releasing, in the first month, we saw that 96% of the top 10,000 eligible experiences on Roblox adopted this technology. So our creator community moved very quickly, not just to create the content, but make sure it showed up in experience. And we saw 115 million users who immediately acquired a piece of layered clothing. So this is not just great technology, this is not just the future, it's that as soon as we release these features, they're adopted and loved by our community. And then we bring your avatars to life. So this year, we released the ability for programmers on Roblox to control 40 different facial muscles. And by combining those muscles, you can create the full range of human facial expression. You can do this for player avatars, and you can do it for non-player characters, like a shopkeeper. And so this brings the avatar faces to life in a way that makes the entire environment more exciting. And of course, when we have these great avatars and they're in great environments, we need the materials to reflect the properties of light correctly. So part of our fidelity to the simulation of reality and doing it at mega scale is making sure that when you have glossy wood, you get the little highlights on it. When you put on a leather jacket, it looks like leather and it has a sheen. When you sit on that velvet couch, that it looks warm and soft. So we're simulating light in a much more physically based way, and we've passed complete control over that to the player community. So the defaults look great like this, but then they can customize it for the look and feel they want. These are just a few of the things we shipped in 2022. Here's a complete list. And of course, we still have a few more months left, so there's more coming. What I want to do, though, is skip ahead and give you a technical preview of where we're going in 2023, because we have some really exciting things that have spent a long time in the lab and that we're going to ship next year. So first, I showed you the programmable facial expressions. That's for creators on the platform. What we're going to do in 2023, and you saw Dave's demo of this on stage, is unlock real-time facial animation for every player in the over 13 group. And what this does is we use your selfie camera or your webcam and the audio channel from the microphone on your device to drive your avatar in real time. So you've seen what this looks like. I think you understand intuitively the value of it, which is that this gives you a sense of presence. Even more than video chat, this is about making it so that when you're in an embedded 3D environment, and you're walking around, you're talking to your friends, maybe you're going to school in Roblox in the future, it feels real and it feels like real people, not plastic mannequins. This gives you lip sync. This gives you winking, smiling, tilting your head. The most important part of the tech stack behind this is that the video never leaves your phone. So what we do is we take the video, we run it through our custom neural network that we developed. We run the inference directly on your phone. The video never leaves your phone, and so you have privacy and safety of that video. And then we reduce it to these 4D muscle parameters, highly compress those, and we stream it out using the industry standard RTC protocol as a special media stream. And what that means is we take tremendously less bandwidth than if you were streaming full video. We only need these 4D muscle numbers for every frame. And that allows us to scale incredibly well. We can enable this for 50 players in the same world, and in the future, we're going to unlock it for even higher numbers. We're taking that same tech for real-time facial animation and bringing it to whole bodies as well. You see, one of the greatest barriers to content creation in 3D is actually animation, not the creating of the shapes themselves. In Hollywood, to make a movie, we have multi-million-dollar motion capture studios, and you've all seen actors in black suits and behind-the-scenes shots. That's not accessible to most of our creators. The alternative is hand authoring. This is quaternion splines, this is advanced 3D animation packages. And again, that's a skill level that keeps animation beyond the ability of most creators. But what we're doing is we're going to use AI to take full body video, put your iPhone in the corner, capture it in the future in real time, and then we'll animate a full avatar in 3D, map it to any character, and run it in the virtual world. Now, we understand that this is a great breakthrough, especially in the way that it combines with our physics system and with our previously hand-authored animations. But in many use cases, you're sitting down, you're in a crowded environment, you're not going to do a full dance. And so for that case, we're also starting with offline authoring. So you can upload a video to the creator tools, to Studio, like Nick just showed you, and then it'll produce that animation, which can be reused for players who aren't in a situation where they can move around. I've talked a lot about efficiency. One of the key parts of our tech stack is the Lua programming language. Now, this is an open source package that we adopted, and then we extended it into what we call Luau, which is our advanced version. We added type inference. We added a high-performance interpreter. And in 2022, we released Parallel Lua, which gives you a 3, 4, 5x speed up, as you can see here, in various kinds of computations. So this gives us efficiency on your device. So if you're on a mobile device, it saves your battery. And it gives us efficiency in the cloud to reduce our cost of operations and scale up more on density. We're continuing to advance Lua in the future. 2023 will have many incremental releases that'll keep speeding up Lua. What I wanted to point out is that when we created our extension, Luau, we released it back to the community as open source. And the reason that we gave it back is, first of all, it's just the right thing to do. We're part of that ecosystem. We want to keep moving it forward. But second of all, it also, when we support the Lua and Luau ecosystem, we see others adopt our technology stack for their products. We increase the number of Lua programmers who are available to create content on our platform, and we get the open source community helping to advance our tech stack. And I want to close with two really exciting features we've been working on for close to decades at this point. The first is real-time constructive solid geometry. Now, there are multiple ways of making 3D shapes. 3D shapes are obviously the basis of games and virtual environments like on Roblox. One of them, which is relatively unique in the real-time space to Roblox, is this constructive solid geometry. And the idea is, this is how, in the real world, mechanical engineers, industrial designers, this is how they make real machinable parts in their CAD systems. So you take shape primitives like spheres and cones and cylinders, and in sort of a virtual machining way, you can subtract parts from them, you can slice off pieces. And you always end up with something that's real, physically simulatable, and physically buildable. It also, for many people, because it corresponds to real-world building and not a computer graphics concept, is a fairly intuitive way to build compared to mesh editing. And so we've always offered this as an accessible way to create shapes on Roblox. But it's also, across the industry, always been an offline tool. It's something you do for authoring, not something that happens at runtime. We figured out how to speed this up by orders of magnitude. And by doing that, what we did is we made it fast enough to run at real time, including in a distributed fashion for our mega-scale simulation. We can run it on your device even. And what that enables is real-time creation, in-experience creation, and real-time destruction. It makes the entire environment more dynamic. So I want to show you an example we pulled together. Everything I've shown you today is real and in experience. These aren't visualizations. We're going to have a firefighter run into a house. In the future, everything in the house will be simulated. The fire, the smoke, the water coming from the firefighters. And it's going to cause the beams to erode. It's going to cause them to crack and fracture in natural ways, not canned, pre-done animation, but live simulation. And so I'm going to show you the firefighter running through, and their axe is doing real-time constructive solid geometry to remove pieces, which will then fall with full physics dynamics. So that's a level of simulation that you just don't see today in other 3D environments. But we're pushing even further. And the last piece I want to share with you in terms of features that will start shipping in 2023 is this airplane video. And what we're going to do here is actually one of the holy grails of real-time simulation. We're doing full aerodynamics simulation. And this is the beginning of a roadmap that leads us through what's called full computational fluid dynamics. So that's simulating, like I said, fire, but water and smoke, different gases all coupled together, simulating wind and clouds, all of that. So normally, if you were going to make a 3D animation of an airplane or a video game or a movie, it's almost all in software. It's in code. So it's not simulated from first principles. It's that somebody has described in a program exactly how the plane should move. So it's, in a sense, it's a hack, we would call it in the tech industry. That's not the way we do things at Roblox. We simulate reality and we do it at scale. And so what I'm about to show you, the airplanes are not hard-coded. There's not software controlling how the airplane moves. It's all first principles physics. It's the way Lockheed Martin or NASA would design a simulation. So we have air over the airfoils giving us lift. We have laminar flow on the top of the cockpit. When the control surfaces come up, we get drag, we'll get vortices. And so that's what makes the airplanes fly. And then you get emergent properties, like a parachute will automatically open because of the air resistance as the air flows in, and objects will have terminal velocity as they're falling. So let's see what our team pulled together. And so that's all real, and it's the beginning of a roadmap that takes us far into the future of full high-fidelity simulation. That roadmap is essentially high-performance computing. It's supercomputer-style simulation brought to real-time 3D. And you might ask, why do we need NASA-level technology to make free-to-play games for kids? And the answer, of course, it has two pieces. One is unbounded creation. So instead of writing code to make those airplanes work, anybody who can make a Lego model or a toy model or a paper airplane, it will just work. We lowered the barrier to creation. You don't need code. You don't need to know about 3D graphics and physics simulation. If you know about the real world and you experiment, things will just work. So we do a lot of work internally to make it very easy for our content creator community to make content. But the second is, it's not about free-to-play games and it's not about kids. That's an important part of our market. That's an important part that we're always going to support. But if we think forward to our vision, to what Dave described, that 50,000-person concert, the energy you get there from that kind of social density and that kind of simulation, from the audio reverberating just like in the real world, for the lights working, from the real photons bouncing around, illuminating things. And then you bring that to other experiences. Maybe it's a giant spaceship battle, or maybe it's millions of orcs coming over a hill. Or maybe it's a university, and we're doing, in the future, augmented reality. And we have those 50,000 people who are not at a concert, but they're going back and forth between lecture halls, and then we're mixing the real world and the virtual world. All of those cases, you need to simulate with real-world robustness and real-world fidelity. Otherwise, you break the immersion and you break the value chain. So Roblox has mega-scale simulation. It's thanks to our key differentiator, which is our distributed computation. That's what lets us build a supercomputer out of every user's phone, every desktop, and then our server cloud. We are driving the future of real-time 3D. We have on our research and R&D agenda serverless computing. It's one of the state-of-the-arts in the back-end server community. We're bringing it to real time. We're using artificial intelligence to auto-tune all of the hundreds of parameters that today are either set by players on a device and other platforms, or in Roblox by our developers. We can automatically change those using AI in a data-driven way in order to give everyone the optimal experience, even on a device we've never seen before. We're doing high-quality visuals, not just on the client side, but we're now exploring how to use GPU computation in the cloud. Now, as I said earlier, we believe in the low-latency, responsive aspect of doing rendering directly on your device. We don't believe in moving that all into the cloud. But on a legacy device, we can accelerate your computation, and we can give you higher quality visuals by giving you a lift with some of the compute on a GPU in the cloud and some directly on your device for low latency. And of course, the distributed computational fluid dynamics that I just showed you with the airplane video. So in summary, there are three key pieces of the engine technical innovation that are leading to a unique experience for players and a unique ecosystem that we've created. The first is our mega-scale simulation, building reality inside of a virtual world and doing it in a distributed way. The second is using all of that power we get from our unique distributed computation to power unbounded creation. Using that overhead, that performance freedom we have, and putting it back into the system so that our players can do all of this mixing and matching so that we can solve really hard technical problems to create a better experience. And what's great is, just as Dan and Nick have previously said on this stage, we do the hard work so that the players and the creator community don't have to. And the third is combinatorial excellence. Our vision has always been, at scale, with full fidelity simulation, to have any physics for any type of part, any type of 3D model, running with any motors, any animation system, with any avatar and any shoes and any hair, any clothes, driving it from programmed animation, from simulation, from your camera through AI, running on any device for any user anywhere in the world and at scale. Thank you very much. That's our engine vision.